Good morning, grade 9s. Today our lesson is on interpreting graphs. But for this lesson, it's kind of hard to show it all on the board because I don't have proper graphs. So I have attached notes to the lesson as well that you can refer back to, and it will do some of the questions that I go over. So when you do look at the notes, in the beginning of our notes, we just talk about when to connect lines and when not to connect the dots. And I've gone through this in my past. So we say a graph is continuous when the dots are connected, and you can only do that when you can use a decimal amount. For example, if you look at the first one, your X is number of cartons. I cannot connect the dots because I can't buy half a carton of ice cream. If I look at the second graph, it's talking about distance in my X. That's continuous. I can't connect the dots because I can't have half a kilometer. So the first part of the notes just summarize the difference between continuous and discrete. And then we go on to today's lesson. It says, how might graphs be useful? They're good for showing information visually. It's easy to read, it's easy to see. But using the graph, we can come up with other information as well. So in our first example, we're going to graph the following data where they give you velocity and time. And I've already set it up for us. And when you're given two variables, you have to figure out which one is a dependent, which is the independent. Independent is always x, and time is always going to be independent. So I know this is my x, this is my y. Okay? So the table of values is given to us. So we start off with that first. They're saying in 1 second, you travel 20 meters per second, and 240, 360, 3. Oh, I wrote 3 twice. It should be 4 and then 80. And I'm just going to fix that. Give me 1 second. So it should be 4 and 80. So your first step is we got to graph our data. So I set up my graph. If you look at my y's, they're going up by tenths. Oh no, I did something weird. They're going up. I messed up here. So I apologize. So it's 40. Then it should be 50. 60, 70, 80. I'll make my graph just a little bit larger. And then 90 and so forth. So they're going up by tenths. If I look at my time, I'm going up by 1. Okay. So letter A is at, let's graph it. So at 1 is 20. At 2 is 40. At 3 is 60. 4 is 80. Based on the data we got, that is our graph. We can connect our dots just on the data that's given from here to here. The reason I'm able to connect my dots is because time, I can have half a second. So I graph my data, I connect to my dots because it's possible. It's a continuous relationship. And then letter A says, describe the relationship between velocity and time. You can use a table, you can use a graph, and you'll say what you notice is as time increases by 1 second, velocity increases by 20 meters per second. It's a linear relation. I know it's a linear relation because this graph makes a diagonal and it makes a nice fit line, straight line. Okay, I will summarize all this up in a second. So that was A. B says, what is the velocity at 2.5 seconds? So they're asking you to use this graph, not algebraically, to find out the velocity at 2.5 seconds. And if I do that, they're giving me the time. So I go to 2.5, which is approximately here. Then I slowly go up until I hit my line. Keep going until I hit my line. And from where I hit my line, now obviously my dots are not perfect, and I go this way, right? So my line is at about 58. So what is the velocity at 2.5 seconds? I would say about 58 meters per second. Then C says, what's the time when velocity is 75 meters per second? This time they give us our y. So I go to y. 75 is here. So I'm going to keep going Sorry, my lines are not the best. That's why I'm sending you some notes. And then from here, I'd go down, I'd go down, I'd go down until I hit. So it's going to be 3 point something, 3.2 or 3.3 seconds. And that's fine. You'll look at my notes. My notes, the answers are a little bit off because I have a proper graph and my graph is done to scale. Okay, so if you see this lesson and you look at my notes, the numbers might not be the same just because my graph here is not as accurate as a graph on the notes. Okay, letter D says, what is the velocity at 5 seconds? So if I'm trying to find my velocity at 5 seconds, if I go up from here, I have no portion of my graph. I can look at my table and continue because I realize every time I'm going up by 20. So I know my answer is 100, but there's no way I can tell on my graph. So using my table, I know it's going to be 100 meters per second. I will summarize everything I just went over in a second. So I just summarized the questions. A, the answer was as time increases by 1 second, velocity increases by 20. What is a velocity at 2.5 seconds? It's 57 meters per second. C, what is the time when velocity is 75? It's 3.2. And D is 100 meters per second. So now to summarize all this, there's two neat new vocabulary that you need to know. One is interpolation, one is extrapolation. Interpolation is when you're trying to find a value or data between the points that are given. So for example, letter B and C, the information, the answers I got is based on the points that I had plotted. They're within this line. So that's called interpolation. Letter D, 5 seconds. There was no graph for 5 seconds, so I used my table to come up with my answer. That's known as extrapolation. You can use a table, or another way you can do is you can take your ruler and extend your graph both ways, going up and down until it hits this axis, and the information you're getting at the extension points, that's known as extrapolation. Those two terms are very, very important, and every single question will ask you that. I'm going to do one more example with you guys, and then you can use my notes plus these two examples to help you with your homework. Example 2. Consider the following graph. So in this particular graph, they give you the graph. You don't have to plot it yourself. That's a monthly cost. That's the number of minutes. Okay, it's going up by 10. It's going up by 10. So your scale is proper. Those are your points. So these questions are based on this graph. So letter A says, what is the monthly cost when 0 minutes are used? If I don't use my phone at all to talk, so at 0 minutes, what's my monthly cost? So this is 0. If I keep going up, my graph doesn't touch it. So what I have to do is I have to use my ruler and extend this graph until it touches. So that it touches right here. So that would be about $33. Okay, so my monthly cost would be about $33, which is my starting point or my initial value. Okay, B, what is the monthly cost when 60 minutes are used? So if I use my phone for 60 minutes, I keep going up. Again, my graph doesn't touch it. So what I have to do is I have to use my ruler and I have to connect to get over here. So if I do that and then I look at and find my cost, so I went up to 60, and from this point I keep going this way, and this is all you can use your ruler. Sorry, it's not the best, right? So it should be approximately $55. And when you look at the notes I give you, it's a lot easier to see. Okay, C says if you want to spend only $50, I only want to spend $50. So how many minutes can I talk on the phone? So if this is 50, right here, I take my graph, I go to my graph until I touch my graph, and then from this point, I go down. If I keep going straight and then I come down, I get about 35 minutes. And this is off from my notes. On my notes it says 45. And like I said, it's because of my graph. Okay? So we can use a graph to come up with information. There's two words I went over, interpolation and extrapolation. If I look at example A and B, I had to extend my graph to get the answer. I had to extend my graph to get the answer. Because I had to extend my graph for both of these scenarios, for these two is extrapolation. For C, it was within the points given. Therefore, that's called interpolation. So these two were extrapolation, and this one was inter because it was within my graph. Okay, so please refer to my notes. Look at this video. Those two definitions are very important. Do the questions. If you have any questions or concerns, please email me or send me a message. I'll help clarify stuff. And that's it. And we will go on to our next lesson on Monday. Thank you. Bye.